let's talk about bond types. And I'm going to distinguish four, two of which are going to be the kind of a joint class. There are ionic bonds, covalent, hydrogen, and I'll tell you that hydrogen bonds are very big in biology. You may not be familiar with those at all, and you need to be. And then I'm going to put together van der Waals and nonpolar or hydrophobic bonds in one class, although strictly speaking, that's not quite fair. From strongest to weakest, the ionic and covalent bonds, and this bottom class are the weakest, with hydrogen somewhere in the middle. Let's take a look at some of these chemical bonds and see what we can say about them. Okay, so I've summarized for you here the notion that ionic bonds are attractions between atoms that involve oppositely charged ions. And so in this molecule that I've shown you here, there is a negatively charged part and a positively charged part, and they are attracted to one another very strongly, and that holds the molecule together. In a covalent bond, the electrons are shared by two atoms. And this contrasts again with the ionic bond, where electrons move to one part of the molecule or to another part of the molecule or to a completely different molecule. And the molecule is held together with the electrons split completely away from one of the atoms. In a covalent bond, in contrast, the electrons are shared by two atoms. And I've circled there a bond between a carbon and an oxygen. It's actually two bonds. That's why there are two lines. And those are two covalent bonds. The hydrogen bond is one, as I mentioned, that is key to life. Hydrogen does not have high electronegativity. It's electropositive, if you like. And so it often has a partial positive charge. This allows it to be attracted to an electronegative atom, which will have a partial negative charge. These two differential dipoles, the positive and the negative dipole, will then hold together two different molecules and form a bond between them. The hydrogen bond is shown by a dotted line. It is not a covalent bond. It is an electrostatic bond, and it always involves hydrogen, hence the name. If you look at molecules in biology and you're not sure what kind of bond it is, if you see hydrogen and then you see some kind of electronegative atom like oxygen or nitrogen, you can be fairly sure that you're looking at a hydrogen bond. And as we'll explore a bit more, and you'll explore in further biology courses, hydrogen bonds are unbelievably important in biology. And then this last class of nonpolar and van der Waals bonds or forces occur between nonpolar molecules where in at least one form there may be very transient dipoles between different molecules that hold the molecules together as a transient positive and a transient negative dipole.